Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about the cosine rule. So this is a video which gives you the proof and solves a little bit questions about the cosine rule of triangles. Right? So before we get started guys, don't forget to explore our website, that is perfect-course.com, our Facebook page to give us your valuable like, and follow us on Twitter, and don't forget to give us your valuable feedback on this email address. So let's go ahead and get started guys. So what I'm going to do is I'm going to start with a simple triangle here, any triangle. Do not mean that it can be a right angle triangle, it can be an obtuse triangle or an acute triangle. I'm saying any triangle. So this is A, opposite to A is A, opposite to B is B, and opposite to C is C, right? So let's suppose if I drop a perpendicular from here and I say, let's suppose this is equal to X. So if this is equal to X and this whole is C, then this is going to be equal to C minus X, right? Because this whole expression is C and this is X, so this is C minus X. And this is, let's suppose, equal to height. Now if I use Pythagoras theorem on C, X and B, if I use the Pythagoras theorem of C, X and B, I'll be able to say that H square plus X square is actually equal to B square, right? So H square plus X square is actually equal to B square, and if I use Pythagoras theorem here, I'll be able to say H square plus C minus X whole square is actually equal to A square, right? So if I subtract both these equations and I eliminate H square, I'll be able to say that X square minus C minus X whole square is equal to B square minus A square. So if I just open this up, if I just open this left side up, it's going to be equal to X square minus C square plus X square this is also minus X square, right? X square minus C square minus X square plus 2CX is equal to B square minus A square. Now let's suppose if I eliminate this X square with this X square, I'll be left with 2CX minus X square, 2CX minus C square is actually going to be equal to B square minus A square. Now from here, if I make A as the subject, right? So I'll be left with A square is equal to B square plus C square minus 2CX, right? And another thing that you need to understand over here is the relationship between B, X and A. So if I talk about this triangle over here, now you know that cosine of any triangles, cosine of any angle. So let's suppose I want to talk about the cosine of A. So cosine of A is actually going to be equal to the base over the hypotenuse, that is going to be X divided by B. So it's the base over hypotenuse. So that means I can say that the value of X is actually equal to B cosine of A. So the value of X is actually going to be equal to B cosine of A. Now if I substitute this value here, what will I get? I'll have A square is equal to B square plus C square minus 2. So C is here. Instead of X, I'm going to substitute B cosine of A. So this is what I have as my cosine rule. That is actually that A square is equal to B square plus C square minus 2BC cosine of A. So if I just rewrite it, A square is equal to B square plus C square minus 2BC cosine of A. Now what I can do is I can do the same story all over again, and instead of substituting X to be equivalent of B cosine of A, I can substitute X to be equal to with respect to cosine of B and with respect to the cosine of C. And this is the result that I'm actually going to get, right? So if I talk about the result, this is the result that I'm going to that B square is equal to A square plus C square minus 2AC cosine of B, and C square is equal to A square plus B square minus 2AB cosine of C. All I have to do is I just have to invert the angle and do the same stuff again. This is what I will get. And as you can see, you have ABC, you have ABC, and you have ABC. And over here you have BC, which is the multiplication of these two terms, AC, which is the multiplication of these two terms, AB, which is the multiplication of these two terms. So if I want to know the cosine rule for all three, I'll write a square, b square, and c square. Now what is left? If a square is done, then I'm left with b square plus c square. If b square is done, then I'm left with c square plus a square. If c square is done, then I'm left with a square plus b square. And I have a negative, 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 2, 2, 2 everywhere. It's b and c, so it's bc. It's c and a, so it's ac. It's a and b, so it's ab. Then what is left? So if it's b and c, what is left? A is left. So cosine of a, ac cosine of b, and ab cosine of c. So this is what we call the cosine rules of triangle, right? So if I, let's suppose, go ahead and rearrange them, I make cosine of a as the subject. That is actually going to be equal to, if let's suppose, if I want to show you from the first one, let's suppose a square is equal to b square plus c square minus 2bc cosine of a. So from here I can also say that 2bc cosine of a is equal to b square plus c square minus a square. If I take the a square there, bring it there, this is what I'll get. And cosine of a is actually going to be equal to b square plus c square minus a square over 2bc. Right? Again, there's a very easy way of remembering this. For any triangle, I can actually find the cosine of a, I can actually find the cosine of b, I can actually find the cosine of c. So how am I going to find that? So I have a, what is left? B and c. So I'll have b square plus c square. Here a square plus c square. Here b square plus a square. Right? So then what I'll do is I'll subtract it from a square, I'll subtract it from b square, and I will subtract it from c square. And I'll divide by 2bc, 2ac, and 2ab. So this is the cosine rule that I've been talking about. You can actually either write it in this way or you can write it in this way as well. So I suppose you're understanding this point over here, guys, and let's go ahead and solve a question on this, just to be sure about that, right? So let's suppose if I have this question. So the question says that I have this triangle ABC. So this is A, this is B, and this is C. This is 6.4 centimeters. Let's say this is 5.2 centimeters, and this is 3.6 centimeters. I want to find the angle A, angle B, and angle C. So the cosine of A is actually going to be equal to, so the value of A is equal to 6.4, the value of B is equal to 3.6, and the value of C is equal to 5.2. So the cosine of A, I'm just going to do for one angle, let's say cosine of A, is actually going to be equal to A square. I'm sorry, it's going to be equal to B square plus C square. So B square is 3.6 square. Plus c square, which is 5.2 square, minus a square, which is 6.4 square, divided by 2 into b into c, right? So this is what you'll get, and once you get the cosine of a to be equal to some value, you can use your calculator and then find the cosine value for that. Now understand, if the cosine comes out to be negative, which is in this case, the angle is going to be an obtuse angle, right? If the cosine turns out to be negative, the angle is actually going to be an obtuse angle. So if you go ahead and calculate this, if you substitute that in the calculator, this comes out to be as negative 0.02564, right? So this is actually something negative, which means you're going to have, as you know that cosine is positive here, negative here, negative here, positive here. That means my cosine of this is actually going to be in the second quadrant if you just calculate that in the calculator. So A is going to be equal to approximately 91.5 degrees. So if A is 91.5 degrees, you can calculate B as well similarly. Otherwise, what you can do now is, since you have one angle, that is, this is 91.5, you can use the sine rule now. You can say A over sine A, that is 6.4 over sine of 91.5, is equal to B over sine B, so that is 3.6 over sine of B, which is equal to C over sine of C, that is equal to 5.2 over sine C. So you can calculate the sine C and sine B and individually the angles as well. As you know that the greatest angle is this, these both angles will actually be less than 91.5 for sure, because in fact they will be less than 90. These both angles would be acute angles, because this is the greatest side opposite to the greatest angle, and these two these two angles will have to be smaller than 90 degrees. So you will always get it in the first quadrant. You will always get them to be acute angles. So suppose you're understanding this point over here, guys. So again, thank you very much for watching this video, and don't forget to explore our website. Everything is there. It's better, it's organized, everything is right here. Don't forget to give us your valuable like, and follow us on Twitter and other social media platforms, and give us your valuable feedback at perfectsource89 at gmail.com. So this would be about this video, guys. Thank you very much for watching. I'll see you in the next one.